Right, hello and welcome guys, and in this tutorial video we are looking at the HackTheBox machine called WriteUp. And this box is very interesting, although he was saying it's an easy box, but I think it's quite tricky, especially the privilege escalation part. So let's have a look. So the first thing I did on this box was to run an mmap scan, so mmap SC, SV, and the IP address 10.10.10.138. And this shouldn't take too long. And the reason I'm actually doing this as regards to, run the scan before is because the enumeration part of this box is actually what makes it quite interesting. So we can see straight away we've got a port on port 22 SSH, and also we've got HTTP service running on port 80. So the best part is to just go for this. Another interesting thing is to see we've got a directory called WriteUp. We've also got the robot.txt file. So what interesting to see exactly what's in these directories. So the 138, and I'm getting an error. So if I do /WriteUp, nothing else here as well. So I'm just trying to ping this box to see exactly what's going on. So do a ping. And we can see we get a response that this box is well alive. However, trying to access the web directory is giving us some issues. So here now we've managed to get here, but let's go back to the initial address on port 80. And again, we haven't got access to it. Go back to WriteUp, do a refresh. Why Puffy? No. So after playing around with this box, it appears this box is actually configured to with a web application firewall. So let's try to run this scan in a different way. So we could do nmap-sa to try to see what's going on. Let's try to refresh this. Nothing. So you can see straight away now we are getting this port 22 saying unfiltered. However, the port 80 is actually not showing. So that confirms that we've got some sort of web application firewall that is actually blocking multiple, multiple scans, and also blocking the SYNAC request we actually sending over the network. So I'm just going to run this one more time to actually see if port 80 is going to come up again, because this is telling us unfiltered SSH. So I was hoping to probably see an unfiltered port 80 or filtered. Once again, port 80 isn't coming up. So I keep refreshing the page to see if at some point the ban is going to go away. And then straight away we can see now we've got 10.10.10.138. So let's have a look at the source page. And here it says not yet live and already under attack. I found an ER DOS protection script that is in place and watches the Apache errors and bans bad IP addresses. So it appears, like I mentioned before, a web application firewall configured. And the sort of web application firewall that will behave like this is probably, after a lot of research, is called fail to ban. So fail to ban is, if you read more about fail to ban, it is a web application firewall that helps to prevent malicious brute force attacks or multiple attempts to log in, probably via SSH, and will reduce the rate of incorrect authentication attempts. So this firewall is actually quite good. I said firewall, sorry. This web application firewall, yeah. is actually quite good because it could provide a level of security for web application. So, if you have a basic web application and you want to defend against brute force attacks, fail to ban can actually be used in order to restrict such sort of denial of service attacks. So that's what I'm guessing is happening on this box. So if you remember in our scan, we also found the robots TXT and WriteUp. So I'm just going to go for this WriteUp to see exactly what's there. And here straight away we get pages. So pages to WiPuffy. WiPuffy is one of the HackTheBox machines that has retired. And here appears to be a write-up for the walkthrough for the box on how it was solved. Blue is also a retired HackTheBox machine. Write-up is this current one. And as you can see, there are some notes regarding the box. So it says this post is still in progress. So the next thing I did was to say, right, let's have a look at the page source. And going straight to this page source, we could see that this web application is actually built with the CMS Made Simple content management site. So what I did was to try to quickly do a search. Maybe there's an exploit. So exploits. And straight away we can see we've got a few ones. So this one is as recent as 2018. Authenticator, remote code execution, file upload. And we've got another one, which is an SQL injection. So let's have a look at all of these exploits. So authenticated, we haven't got any credentials. However, if you read through this, it says if you go to this admin module face PHP, we should be able to have a login page, I guess. So let's have a look at this. So paste this here. And we're prompted for login. We don't have a, so I try admin, no lock, admin, tab password, admin, administrator. And we're getting nowhere with this. So we know this web application has got a web application firewall configured to prevent DDoS attacks. So if we try to brute force, do an HTTP login brute force, we're probably going to get banned and won't be able to complete the brute force. So unauthenticated without credentials is quite difficult. So that eliminates most of these exploits. Also, this requires an authenticated remote code execution. And if we have a look at this one, it says access to target CMS install by installing the CMS Made Simple. We'll be able to do some tricks. However, the one I found that was quite useful is this one on PacketStorm, which is an SQL injection. So download the exploit. And we could do nano, we just call this exploits.py, paste it in, save the exploit. And when we do Python exploit.py, try to see what exactly is happening. So it says here, specify a URL, example, no cracking password, example with cracking password, the URL, and then you supply a directory word list. But let's go back into the script to see exactly what is this script doing. Let's see if I can zoom in a bit. Yeah. So if we go in here, we can see it's a very recent exploit, which is as early as, recent as 2019. So it shows this exploit will probably work because this box also was released in 2019. And this was actually released in 2019 March. So I'm assuming this exploit is probably very recent and it's tested on Ubuntu 18.04, which is, very recent Ubuntu distribution as well. And you can see from the CVE 2019. So this is a very good indication. So this is the usage where we can actually see the URL, the vulnerability is actually being exploited on this directory. So let's see if we can have access to this directory. So let's go in here, paste this in, and see what happens. And you can see straight away, we can see we've got this new module installed by JKR, and JKR is actually the author of this box. So it appears we got this module or plugin, whatever, installed, and that probably should be what we should be exploiting. So let's go back to our exploit script. So it means we could just supply the URL, which is 10.10.10.138 and slash WriteUp. So if we go back to the exploit script, we can see it actually puts the slash, so we don't need to put that in our exploit. So we could do crack because we wanted to crack the password and we provide password list. So we just use USR share word lists and we provide the rawq.txt file. So run this exploit and it says what? Something wrong. Oh, right, we have to provide the URL flag. So -u, and we run this exploit. So it's going to go ahead and try to see if we could perform an SQL injection. Let's go back to the exploit script. He's going to run, try to brute force the email, salt, and crack the password. So this is a function to crack the password. And it's going to perform that using the salt. And calculate a digest, an hexadecimal digest, and if that equals the password, he's going to print out the password. So he's going to go through the dictionary word list, and so I'm assuming from this exploit showing that the password which is being stored on the web application is being hashed in MD5. So he's using the MD5 algorithm and then calculating the string of the salt and using that. So the salt plus the password, and then it's going to calculate a message digest. And if that equals the password in our list, and then it's going to say password cracked. So you can see straight away it's found the salt, it's found the username, JKR, and it's also brute forcing the email. This is actually a very cool exploit with the look of it, because it's it's doing stuff probably I haven't seen another exploits doing. So in real time it's actually cracking this, and it's going to use this in order to brute force for the password using our password list we supplied. So I've done this initially before, and this is actually going to take some time, especially the brute forcing part. So I'm just going to cd back into my directory. So cd HackTheBox. And I'm going to go back into WriteUp. I'm going to cat the credentials. Okay, so this is what is going to happen after this finishes. It's going to get the salt, the username, the email, and the password. And then it's going to calculate that, brute forces against, compare it against our table, and eventually this is the password. So the password, if you remember from our enumeration, we found an SSH. So what I just did straight away was to try SSH. So we have JKR at 10.10.10.138, and click on enter, provide the password, and we're logged in. So if we do a list, because straight away you've got user.txt. I didn't reset this box, so this file I'm assuming is from other users on this box. And we can just do wc-c user.txt. And there we go. We got the user. So that was pretty cool. And you can see straight away it's trying to brute force the password, and eventually it's going to crack the password and tell us the password is RayKJ9. So for privilege escalation, if I go into the temporary directory, do a list, it's actually a lot of stuff here, so I'm going to get rid of all of this stuff. Okay, so there's nothing in this directory. And I'm going to go to my Kali Linux machine, cd tools, and ls grep linenum.sh, so the Linux enumeration script. Before I do that, I'm going to do an if config. It's on 0. So we've got this, and I'm going to start my Python HTTP server. HTTP server -80. Okay, so I'm going to go in here straight away and do which wget. So we've got wget installed, wget HTTP, and I'm going to provide my IP address, which is 10.10.14.209. I'm going to give it linenum.sh. Download the enumeration script saying 404. That's because I didn't spell this correctly. Okay, so we got the script. Go run bash against the script, linenum.sh. And we're just going to enumerate to see exactly what is going on this box. Are there any processes running? Are there any SUID binaries? Are there any other users on the box? And, and so on. So we go back into here, and this brute force is still going on. I just want to make sure it finishes for you to actually see that the results we got was correct. So our enumeration script is finished, and we could go to the top and start to look through this. So disabled SUID, GUID, and Linux WriteUp, and we can see it's a 64-bit Ubuntu Linux machine, and hostname WriteUp. The user is JKR, and it belongs to this other groups. We've got another user roots, and that's the other user. When we go in here, the only user is JKR. Has got a bean bash as well as root. So those are the two valid users that could log in, trying to see if there are any cron jobs, and nothing is actually coming for. So the next thing I did was to do a PSAUX auxiliary and see all the processes running as root. So grep root. And here you can see, like we mentioned at the start, we've got a fail to ban server. So we got the script, the Python script is the fail to ban server, which runs in order to protect the web application from denial of service attacks. So we could actually go and cut this file to see exactly what's in this file. And this file is actually being executed by root. So we can see the script, failed to bind, designed to protect your server against brute force attacks. Its first goal was to protect an SSH server. So we can see the script, and the script will try to detect if someone or a malicious attacker is trying to brute force and then bans that IP for a limited period of time based on the configuration the setup of this box has been put to do. Anyway, going back to the results of PSAUX, grep root, we can see the root user is running some So there's a bean bash to probably start up MySQL, and fail to ban is also being started up. But if you can see fail to ban here, if we have a look at this file, so we do a list to see the file permissions. You see this file is owned by root. It's only executable by anyone else, and we don't have write permissions. So if you had write permissions to this file, then probably we could, write our own commands into this file, and when root user or the cron job who tries to ban IP addresses for denial serverless attack, then root can then execute the script in order to do whatever it is that we've put into the script. However, we don't have write permissions to the script, therefore we cannot exploit the script. So the next thing to do was to download the PSPy. So PSPy is a process enumeration script. So PSPy, I think it's called PSPy, GitHub. And you can see monitor Linux processes without root. So it wouldn't monitor all the processes, and I think it's written in Go. And you can download whatever versions you want. So you can download. So I think these are the compressed ones. So a 64-bit version, a 32-bit version. And if you remember, if we go back to our box and we do uname.hey, we can see the Linux machine is actually running a 64-bit version. So ideally, this would be the script we need to download. So I think I've already got the script. So if I do a list, pspy, I'm just going to grep for that. So I've already got the script in my tools directory. So I'm just going to start up my HTTP service, wget. So we could do wget, and we go for pspy 64 s, download the script, make the script executable. So shmo-x plus x, then we do pspy 64, and then we try to run the script now. And it's going to enumerate processes that are running, and straight away we could see probably there are a lot of users on this box. However, we could see straight away SSH JKR is logged in, so the user JKR is logged in, and some operations are performed. But however, if you look at the UID here, we can actually see the one is actually performed by root. So the group user, or the root user, I beg your pardon, is UID 0. So you can see the root user execute this loggers command, perform some operations on SQL, and runs the fail to ban Python script. Okay, but it would be interesting to actually see what happens if we try to log in. So we might try to log in as the user JKR from a different terminal. So JKR SSH JKR at 10.10.10.138. And I'm going to try and grab the password. So we could cancel this, clear screen, and then I'm going to try to run this again. However, I need to grab the credentials for that user. So HackTheBox, and then we go on to WriteUp, credentials. So go to credentials here, copy the credentials. Let's just see if our brute force has finished. Still running. So that's going to take some time. I'm just going to end this because this is probably going to go forever. So, well, as you can see, we got the password, and that's actually what matters. So I'm going to exit this screen. So now if we go on to here, click on enter, SSH, run the script, Go back in here and paste in the password. So I'm just going to wait for this to run. Okay, and we paste in the password and click on enter. You can see straight away we begin to see the PSPy actually running. So we're trying to monitor the processes as we log in. So we can see something quite interesting is happening here. We can see the root user is running a script. So he sets the environment. All right, so he's setting the environment part. So I'm just going to end this here. Setting the environment part, and it's putting the part user local has been setting the part, and then it's calling this file called run parts to print out the message of the day. So the message of the day is actually the message we see once we logged in. So if you remember when we logged in here, we got this message of the day telling us, the Linux version and giving us a banner. And if we try to cat this file, so let's cat this file to actually see that's what we're getting. It says the directory, so we cd into the directory and do a list. And this file here, if we cut this file, so it says bin sh. So let's have a look at this one here. So cut this file. There's nothing in here. But the message of the day, update message of the day. So let's go back here and see what happens. So if you locate MOTD, so we got etc MOTD. So I think that's the file I'm looking for. Yeah, so that's the banner which actually gets printed out. So I think this file, run parts, is doing some magic with this file and then sending it to another directory called, or another file called run.motd.dynamic.new. However, the exploit here is that the run parts here is actually a binary. If you go onto our own machine and we do locate run parts, we could see the part where we've got run parts is actually /bin. So the root user is not actually declaring the full part. So for instance, I could do stuff like, let's just do an example. You could do stuff like, if I do stuff like bash, I get a prompt. If I do locate bash, we could actually see the full part. So let me just run back to the top. I can actually see the full part for bash is actually in bin bash. Even though I'm running bash or as a command, I'm not actually specifying the full part. So if we do bin bash here, bash actually executes as well. So it's possible to actually hijack this binary by writing our own run parts binary and then putting it into the part of root. So when root is looking for this run parts binary, it's going to go into these directories to search for that binary, and eventually it's going to find it in /bin. Once it finds it in /bin, it's going to then run parts. So because this binary hasn't got the slash like we did before, so hasn't got /bin /run parts in front of it, we're going to hijack this, and once we log in, the root user would execute the script and hopefully execute our own scripts. So I hope this makes sense. It's kind of complicated, but I think once we get into this, you'll be able to understand it much better. Okay. So I'm going to close this. Going to go back to temporary directory, list. I've got my PSP directory here on my PSPy. I'm going to run that again so we can actually see the events. We're going to exit this, log in again. So we've got password. So we're going to log in again as this user. Okay, and paste the password in. And you can see once we logged in, SSH accepted, and then you can see this is the command that is being run. So I'm just going to end this here. So let's go into this directory called sbin, which is the first part. Root is going to try to look for this run part binary. So let's go into this directory and see what's going on. So cd into this directory. So if we do a list, it says permission denied. However, if we do stuff like touch test to see if we can write to this directory, we don't get the permission denied. So we do have write permission, but we don't have read permission to this directory. So if I do file test, it tells me the file is empty. Okay, so we could do file test again. And let's see, file test. And it also says the file is empty. So we can also delete the file and the file is gone. So we do have write permissions to this directory. So all we have to do then is to create a binary called run parts and place this binary in this directory in order for it to execute whatever malicious exploits we want it to do. So this is going to get quite interesting. So here, I'm just going to go over to this always on top, cd temp. So I'm in the temporary directory, got temporary directory there. I'm going to open another terminal on my Linux machine and just look for a default exploit binary that I've got. So I'm going to look for locate exploit.c and I'm going to go for probably this one. So cat exploit.c. So just a basic SUID binary, which is going to set UID 0, set group ID 0 to root, and then execute bean bash. So I'm going to copy this. I'm going to cd into HackTheBox and cd WriteUp. And I'm going to create a file called WriteUp within this. So I'm going to call this, I'll call this exploit.c. Paste in the binary. Okay, so we've got a binary that's going to execute bean bash. Save that binary. And I'm going to compile this. So let's just make this bigger. So gcc exploit.c. So you got exploit.c here. Outputs, I'm going to call this WriteUp. Remember, we actually executing this on a 64-bit Linux Ubuntu machine. So I'm going to put M64. So it compiles it as a 64 ELF file. And that compiled. And now if we do file WriteUp, we can see it's a ELF 64-bit file. Okay. So I'm going to move this file. So I'm going to copy this file. I'm going to copy the WriteUp file, WriteUp, to my Python HTTP server, which is in my tools directory. So tools, and I'm going to place in WriteUp there. So I've got WriteUp going there. Now I'm going to go back to this exploit script and do something. So nano exploit.c, and I'm going to change what this system is going to call. So we're going to create another file, and I'm going to call this system, and I'm going to say cd temp. So it's going to go into the temporary directory because this is where we're going to put in our WriteUp script. I'm going to say cd temp and change ownership, load the file to root. Okay, and set SUID, so chmod u plus s. So change ownership, given the file name, WriteUp, and change this, set the SUI bit on this file, WriteUp. Okay, so this file is going to execute this system command. So it's going to cd into temp. It's going to change the ownership of the file to root. So root owns this file, and then it's going to set the SUI, the binary on this WriteUp file. Okay, so let's clear screen. We do GCC exploit, and this one I'm going to call this run parts. So run dash parts. Okay. So we got, if we do a list now, we've got two files. So we've got WriteUp, which is the one that's going to execute bin bash, and this is the one that is actually going to set the SUID bit on this file, and also set change ownership of this file to root. So once this file is downloaded here, we download this to the sbin directory. This file would then execute the command in order to change this WriteUp into an SUID binary. So basically, that's what we're going to be doing. So if we go back to this directory, we could go back in. So grab the password to SSH back in. So SSH back in here. Okay. And the directory we go in is this directory here. So we could just clear screen first, cd into this directory. Okay, we're in this directory. Obviously got a shell in here. The shell has died. So here again, we're going to go back, paste the password. And we logged in. Paste the password, copy that in here. Yeah, so we logged in into two sessions. And here we're going to go into the temp directory. So /temp directory. Okay, so we're in the temp directory here, and here we're in the sbin directory where we have write permissions. So if we go back to our Kali Linux machine, I'm also going to copy run parts. So I'm just going to copy this file to my Python HTTP server, which is already started. So I'm going to move this to root/tools, and I'm just going to move this here. So if config is on 0, if we go in here, we can do wget, paste this here, and we do WriteUp. We download the WriteUp file. We got the file. If we do a list, we got the file. We're going to make this file executable. So we're going to do chmod-x. We're actually going to make everybody be able to execute this. So chmod others plus x, make it executable, WriteUp. And we got the file. So if we do a list now, you can see the file has gone green because it's executable. And I'm going to do the same thing here. Copy this. Go into the other directory. So permission denied. We're going to do wget. And we're going to fetch the run parts binary. So we've downloaded the file. We're going to make the file executable. chmod plus x. And we're going to make it run parts. So the file is executable. Now we're going to exit here. And once we log in again, that file is going to get called. So quick one, copy this, go over here, paste in the password. Once we paste in the password, if we go to cd temp now, and we do a list, our WriteUp file is actually gone red because it is now an SUID binary. So now we can execute the WriteUp file and we're root. Boom. So cd root list, and we can actually see the root flag. Okay, wc-c root. .txt. So what happened? So let me just go through what happened again. So the thing is, we found out that the root user is actually using the run paths binary to execute some certain message of the day banner once the user is logged in. But in order to see this, you have to be logged in two places in order to be able to see this process run. So what I did was, because the run part being called wasn't called with a full part, so the user wasn't, like I mentioned, if we do locate on our own box, we do run parts, which is a Linux binary. Run parts actually is located in the /bin directory. So because the file is not actually being called with a full part, if we write a malicious run part binary, which is going to get executed by the root user, we place it in the root user's part, and all we did was to make this run part file turn our WriteUp SUID binary to be WriteUp file, to become an SUID binary, which you can actually execute. So you can see here it is SUID binary set. It is executable, and then once we execute it, we become root. So I hope you've enjoyed this box. Enjoyable because I actually enjoyed the first local privileged user in order to run that exploit. I think it was a very cool exploit, and I think this took me a little bit of time. However, it's actually very interesting if you understand how file permissions and file paths work in Linux. So this takes you back to basics, especially this sort of box, and I quite enjoyed it, and I hope you did as well. So thanks for watching, and I shall catch you at the next one. Cheers.